Hey guys, welcome back, and we are going to be discussing some review material today. Nothing new, which is going to be really nice. Just taking everything that we've discussed so far this year and kind of putting it all together, being able to recognize the situations that we've learned about and deal with them efficiently and economically. Our target here for this chapter, which is only one target, one thing, is that we hope that you guys can solve, graph, and identify key features for all the functions that we have learned about this year. So we're going to dive right into the very first question. We're going to give the name of each function, and then we're going to be solving for the variable, solve the equation. Number 1 reads 2 plus 4 multiplied by the quantity, parentheses, x plus 9 squared equals 10. So if you were looking at that, because we have this little exponent of a 2, I hope that you guys know what type of an equation that is. If you've done your work so far this year, you should know that's a quadratic. So we're going to eventually be getting rid of that exponent and getting inside to where the variable is at. The first thing we need to try, though, is getting rid of the easiest things, the things that are furthest away. And so that would be the 2 at the very front in this case. So taking that 2 and moving it to the other side with the 10 means I need to subtract. So subtract 2 on the right, subtract 2 on the left. That just leaves 4, and then in parentheses x plus 9 squared equals 10 minus 2 is 8. In order to get rid of that 4 in front, you do not want to distribute. That's a common mistake. You can't distribute here because the exponent has a higher priority. The exponent's really in control. And so in order to get rid of that 4 that's in front, you need to divide by 4. 4 hooked on front is multiplying, and the opposite of multiplying is dividing. So divide the right side by 4 and divide the left side by 4. Luckily, 8 is easily divisible by 4, and that's equal to 2. So now I have the parentheses, x minus 9 squared equals 2. Now how do we get rid of a squared? How do we get rid of that exponent of 2? Well, if you remember, the opposite of that exponent is a root of a similar size, and to get rid of the 2, you need a square root. So we're going to square root the right-hand side, and we're going to have to square root the left-hand side as well. You can't just square root one side and not the other. You have to maintain balance in this equation. So when we square root 2, it doesn't break down to a prime number. We're going to leave it as square root 2. That's the easy part. If you're more of a decimal person, that's about 1.41, 1.4142, and it keeps on going. On the left-hand side, though, where the x plus 9 was, something unusual happens here. The square root and the square, they blow each other up, essentially, but we're left with something, a byproduct. And that deals with what the smaller of the two operations was. Because the inside of this is a squared, and you are square rooting that squared, you're going to end up getting absolute value bars here, and there's a reason for that. I have a cool demo, a visual, to show why we're getting absolute values. But the logic behind it, and why this makes sense in my mind, is you have to ask yourself, well, what types of things can I square? What types of things can I raise to the power of 2? You can raise positive numbers to that power, and you can raise negative numbers to that power as well. Anything is possible to square it. And so when we get our answer, we can have a positive version and a negative version, since both of those things were possible to put inside that innermost layer. This will contrast a little bit with the next question. You'll see how they're different here in a second. So once we go ahead and we put those absolute value bars around the x plus 9, we have to get rid of those. We don't want those bars. They're keeping us away from the variable here of x. So to get rid of absolute value bars, we put a plus or a minus on that other side. Now we just have x plus 9 equals positive or negative square root 2. To get rid of the plus 9, which is the only other thing over there on that left-hand side, we're going to just subtract 9 and subtract 9. Now, you have to recall, subtracting 9 goes in front of the plus or minus sign. You do not get to put it inside the root. You do not get to budget in between the plus minus and the square root number. It has to go in front. So our final answer here is -9 plus or minus the square root of 2. Now, if you are more of a decimal person, and you were trying to find those two different answers when you do the math, it's about -7.58 and -10.41. So those would be the two solutions that make the entire equation balance, that you'll get 10 on the left-hand side and then 10 on the right-hand side as well. So that's how we solve that first quadratic. If we look at number 2, though, number 2 is not a quadratic. It says 2 plus 4 in front of this root. And inside the root, we have x plus 9, and all of that is equal to 10. So there are actually a lot of similar numbers. The only thing that's different between question number 1 and this problem is that it's not a quadratic, it is a root, specifically a square root. And so thinking about how to solve square roots is what we want you to be able to do here. First steps to solving this and getting all the way down to the x is to get rid of that 2. Adding and subtracting is one of the easiest things to get rid of in an equation. It's easily moved. So I'm going to subtract 2 from the left and subtract 2 from the right. I get 4 times the square root of x plus 9 equals 8. And now I have to divide by 4. That 4 does not get to distribute in to a square root, just like it didn't get to distribute into the parentheses squared. You can't do that. In order to get rid of that multiplying by 4, you must divide by 4. And do that on both sides. Once I divide by 4, I'm going to be left with x plus 9 inside of the square root. 8 divided by 4 is 2. Now, how do we get rid of a square root? It's trapping the variable inside, and I don't want it to be trapping the variable. I want to get rid of that. So what would undo a square root? Well, if you remember from our radicals chapter, exponents get rid of roots. And so I need an exponent that is appropriately sized to get rid of a square root. And that would just be to the power of 2. A squared and a square root cancel each other out. So I'm going to go ahead and square the left-hand side and square the right-hand side. You can't just square one side and be done. You have to do both sides at the same time. And so here, 2 squared is pretty easy. You just get 4, 2 times 2. But on the right-hand side, I said that the square root and the square cancel each other out. Am I just left with x plus 9? Or do I need absolute value bars here? This visual is a little bit weirder. I'll try to put that up over onto the side. But the logic behind it makes a lot of sense. Remember, you're concerned about what's the smallest layer. So inside we have a square root. What types of numbers can I square root? That's what you should ask yourself. And so you can square root positive numbers, that's fine. Square rooting negative numbers, though, that might seem weird to you because that would produce imaginary numbers. Square roots of negatives are not something that you typically want to deal with. Not possible, they're imaginary. And so we can't get a positive and a negative number to work in that situation. We need to only be using the positive numbers. So I'm only going to be having the positive results, which means I actually don't need absolute value bars there. Absolute value bars mean plus and minuses could work, but here only the positives work. And so there are no absolute value bars here. I only have the positive version. So once we know that, we have x plus 9 equals 4, and you just subtract 9, similar to question number 1. 4 minus 9 in the end is -5. So there is one solution in this problem compared to having 2 solutions for our quadratic. The bells for you, as the size of the exponent tends to dictate how many answers you will get. The fundamental theorem of algebra is what that's called, if you go back and look in your notes. Question number 3 reads x squared minus 6x equals 16. Now, if we're trying to identify what this is, it has a squared in it, but then it has this x term as well, and it's equal to 16. If the biggest term is a squared term, something to the second power, then we know it's a quadratic. This is just a quadratic that's written in a slightly different form. So up above, it was written in vertex form, where it tells you the directions to go to the vertex. Here, this is in ABC format, standard format, where all of the terms are lined up kind of like the biggest down to the smallest. So if we're going to be solving this, you have to remember what tools we have available to us. We could factor, we could complete the square, or we could use the quadratic formula. All three of those things should go through the back of your mind. Now, in order to get this set up for those different tools, we typically go ahead and move everything to one side. So I'm going to take that 16 and subtract it over to the left. 16 minus 16 on the right-hand side equals 0, which is good. And then I put this minus 16 kind of at the end. It is the C term. So this problem looks like x squared minus 6x minus 16 equals 0. I typically like to factor these things. I'm just better at factoring. It's pretty quick, although completing the square will work if you remember how to do that. And the quadratic formula always works. It just takes a lot more space. There's a lot more work to it. So factoring this, I typically like to do the x factor, where the top is a times c. So 1 times negative 16 is negative 16 up there. In the bottom, the b value slides down to that position, and so that's negative 6. The game here, if you recall, is to multiply to the top, but then add to the bottom. What multiplies to negative 16, but adds to negative 6? If you're sharp and you know your multiplication tables, that's just negative 8 times 2. That'll multiply to the top number, but then 2 minus 8 adds down to the negative 6. Now here's where the x factor is cool. You got to put this over the a value. So I divide by 1 on both sides, which typically dividing by 1 just means you're done. This is a simple quadratic to factor. So taking those two fractions, the one on the left and the one on the right, I'm going to go ahead and make my two factors. So I have x minus 8 in the first factor, and that just comes from the denominator and the numerator. Those two numbers are important. And then x plus 2 is my second factor. Now this is still equal to 0. And so solving this, I want to know what values would make this equal 0. So anything times 0 is 0. So one of the factors, or both of them, equals 0. So x minus 8 could potentially equal 0, and I add 8 to both sides. And the x value that would make that 0 out would be 8 itself, 8 minus 8. And that would make this statement true. 0 on one side equals 0 on the other. If I take my other factor, which was the x plus 2 factor, and I'm trying to figure out what would make that equal 0, I just subtract 2 and subtract 2. And so now I'm left with x equals negative 2. Those two values are the only things that make the original question true. X equals 8, x equals negative 2. Solving quadratics was a big chapter and something we focused on a lot, so I hope that you recall several of those steps. You might just be a little rusty at doing those, but that's why we're doing this chapter in the first place. Number 4, if we look at that, it's not really a quadratic. It has an exponent, but this exponent's a fraction, which is not the nicest thing. We'll talk about what to call this in a second. So it reads 2 plus 4, and then we have a quantity x plus 9 raised to the 2/3 power, and that's equal to 18. Being a fractional exponent, this is more of a root. If you recall, we can always take fractional exponents and transform them into a root with an exponent inside. So it's a radical root sort of equation. And that's going to be the big issue, is getting rid of that weird, gross, yucky exponent here in a minute. As you can probably guess, the very first thing we're going to have to do here is get rid of the 2. So we're going to subtract 2 from the left and subtract 2 from the right. 18 minus 2 produces 16. Now we have that 4 in front on the left-hand side that I got to get rid of it. You cannot distribute. You have to divide to get rid of the 4. So divide by 4 and divide by 4. 16 divided by 4 produces 4. Now I'm left with the parenthesis, the quantity is what we call that. That group is raised to this 2/3 power. Fractions, right? Well, if you remember how to get rid of those yucky fractions, I typically put brackets around those sides. So I'm going to bracket, I'm going to cage that left-hand side in. And to get rid of fractional exponents, you simply raise it to another exponent that is its reciprocal, the flipped version. Because if you have something in the top and the bottom of a fraction, those typically cancel out. And so the bottoms and the tops will eventually annihilate each other. They'll reduce down to 1. But if I go ahead and I take the reciprocal of 2 over 3, which is 3 over 2, I have to raise the other side to that exponent as well. Boo! Well, here we have 4 raised to that 3 over 2 power as well. And here's where you have to be sneaky. 4 is a perfect number. If you realized 4 is just 2 squared, then you're doing exactly what you need to do. All right? So, the 2 squared and the 3 over 2 as its exponent, remembering that exponents raised to exponents, you just multiply them. I have 2 over 1 times 3 over 2. And the 2 and the 2 in the numerator and denominator, they cancel out. They're gone, which leaves just 2 to the 3 over 1 power, 2 to the 3rd power. That's something that you should know. 2 times 2 times 2. 2 to the 3rd power is 8. So all of that stuff on the right-hand side boils down and leaves you with 8. Such a beautiful number. But on the left-hand side here had that quantity, the x plus 9 group, and it had 2 over 3 and then 3 over 2, which those canceled out entirely, which thank goodness leaves us with x plus 9, and that's it. So I have x plus 9 equals 8. All I have to do to get the x by itself is subtract the 9 and subtract the 9. 8 minus 9 equals -1. And so that's my solution for this radical or this root problem. It's really gross, okay, to start off and try to get rid of this exponent, but in the end it turned out to be a nice number. All 4 of these questions on the front of our notes are things that we have done so far this semester, and I hope that it's just kind of a review and a recap, and that you just needed a little refresher on some of those things. Let's take a look at the back. The back of these notes deals with some graphing again. Good old visuals, right? Coordinate plane. Woo! So number 5 deals with f of x. Good old Frankie! And it's equal to -x squared plus 8x minus 15. If you got that in the back of your head that that is a quadratic, then you're doing exactly what we need you to do. It's a quadratic that's in ABC form. Everybody's lined up. The negative in front, though, tells us some pretty important information. It says that instead of opening up as a U, it is going to reflect and open down. It's a vertical reflection. So end behavior-wise is going to be going down and down. Now, if you remembered from the polynomials unit, things that are in the standard form, A, B, C, or if it's bigger, A, B, C, D, E, F, G, however far, it's that very last value, the constant, that tells us something about the graph that's important. So in this case, that minus 15, the baby at the very end of the equation, it's telling us the y-intercept, where we cross on that vertical y-axis. So in my head, I put that point all the way down at the bottom. That's important. I'm anchored there. But where the rest of this graph is, I really don't know. I know it's down and down, but that's it. There's not a clear picture, besides knowing that it's a U. Off on the right-hand side, we can go ahead and talk a little bit about our key features. The key feature we just found was the y-intercept at 0, -15. But right above this, it was the x-intercepts. How in the world do I find x-intercepts for this? One thought that comes to mind is maybe rewriting this in factored form. If you remember with polynomials, writing things in chunks, in groups, in factors, that told us exactly where it crossed the x-axis. So that would be beneficial right now. Knowing where it crosses that horizontal x-axis is what I want for those x-intercepts. So let's take the original equation, the ABC form, and let's try to factor it, split it into those chunks. So -x squared plus 8x minus 15. The first thing that I don't like is the negative up front. So we're going to divide it out. And I'm doing this keeping in mind that I want to factor. Factoring doesn't like negatives in front. So once we divide out a -1, all the signs just flip. And I'm left with x squared, which is positive now, minus 8x and then plus 15. Everything's just kind of opposite. If I take that and I try to x factor, okay, the a times c goes in the top, 1 times 15 is 15, and the b value drops down to the bottom, that's negative 8. Can I multiply to 15, but then add to negative 8? You have to use those multiplication tables. And that just says to me, negative 5 times negative 3. A negative times a negative makes a positive, but then when you add two negatives together, they just stay negative. So negative 5 plus negative 3 is negative 8, and those two things multiply to positive 15. Now, dividing in the x factor here is very important. We divide by the a value, and that a value is now 1. It's not negative anymore. If you have a negative on the bottom of both sides, the x factor can't handle that very well. So we have negative 5 over 1, and we have negative 3 over 1. Writing those in factored form, bottom of the fraction, top of the fraction says 1x minus 5 and 1x minus 3. You could, if you want, just write x minus 5, x minus 3. Now, there is something important that we've forgotten to bring along through the work, and that is the negative that we divided out right away. Okay, we went fishing and we pulled out that negative. That negative is important and it goes in front. That tells us that the whole graph has been reflected, flipped over. So here, going back to the factored form, the grouped form, I need to find what x values make that equal to 0, because those are my x-intercepts. So x minus 5, the x value that zeroes that out is positive 5. 5 minus 5 equals 0. And so 5 is going to be one of those x-intercepts, 5 comma 0. We can write that up top. The other value that makes this whole thing zero out is the value of 3. 3 minus 3 makes it 0, and anything times 0 is still going to give you 0. So we have x equals 3 and we have x equals 5. Those are our x-intercepts, and so we can write them up in the key features table. What this does for our graph, if you're looking over on the left-hand side, is it puts those 2 points on the x-axis, 5 comma 0, 3 comma 0. And they are very close together. They're super close. What I can do is I can take those 2 points, since they're at the same height, and I can split their distance. Because I know U-shapes are symmetrical on the left and the right-hand side. And so all I have to do is figure out where that central point is, that vertex point, and then the rest of the graph will reveal itself to me. So I know right in between 5 and 3 is the x value of 4. 4, for that x value, is where my vertex has to be. That's the axis of symmetry, something we talked about a long time ago. So if I put 4 in, and I know this is a lot of work, but if I put 4 into my original equation to figure out the height or the y value, then I'll know exactly where that graph has to start. So let's try that. Putting 4 in, I have negative 4 squared plus 8 times 4, since there's another x in that spot, and then minus 15 at the end. Well, if I take negative 4 squared, that's negative 16. If I take 8 times 4 in the middle, that's plus 32, and then minus 15. If you go ahead and take negative 16 plus 32 minus 15, your end result is 1, positive 1. And so I know at that x value of 4, I have to be at a height of 1. 4 comma 1 is the vertex, the center of this graph. So going over 4 and up 1, and I plot my point down there, you can see those 3 points start to form an upside down U. That's the center of our graph. Whew. We're almost there, except that we have to connect those points with the rest of the shape. We aren't very high definition yet. We're like 4-bit pixelated image. We don't have a clear view of where this U goes. And if you remember the pattern that goes with U's, with parabolas, with quadratics, it's that the spacing between points gets larger and larger and larger. And it follows the pattern of being 1 times a, 3a, 5a, 7a. It's all the odd amounts multiplied by your a value. And in this case, our a value is just negative 1. So you can see that in the vertical spacing is just negative 1, 1 times negative 1. Our next gap, as we go from the 2 points below the vertex to the next 2 points after that is 3 times a. 3 times -1. So those next points have to be 3 below where you were. And then their spacing to continue on is 5 times -1. Then 7 times -1. Then 9 times -1. That pattern is something that you should remember from first semester. So we have a spacing of 1 down, 3 below, 5 below. And then what happens if you continue 7 below? Do you remember that Y-intercept point that we put there? It's the very first key feature. Well, if I go 7 below from that point there at 1, -8, I land at 0, -15. So all of this fits together like a giant puzzle, which is why math is so cool. Everything fits. And so you have ways to check yourself and make sure you're doing things correctly. Whew. That was a lot of work. We're almost done, except for the key features. So let's talk about domain and range for this picture. The domain, or the x values where this gets to go, is endless. It doesn't stop going left and it doesn't stop going right. So we can say all real numbers. We could give the interval of -infinity to +infinity. Both of those are fine. I'm okay with either. The range is a little bit harder because this has been reflected. That means there's a space up above that it doesn't get graphed at all. And so I'm going to go ahead and say from -infinity, it keeps getting graphed all the way up until I hit that ceiling at 1. And what you put at 1 is important. We need a bracket at 1 because you can actually equal a value at that point, okay? Because you can actually stand on that point. It's a solid point. So that height is something you can stand at. At the very bottom of this key features table is something we haven't discussed in a while, called positive intervals and negative intervals. The analogy that goes with those is when are you above the x-axis, when are you an airplane, versus when are you below the x-axis, when are you a submarine. So you have to think about being above in the air and then below swimming in the water. And that happens in a couple of spots here in this graph. We can see that it starts below, so from -infinity all the way until what x value do we break free of the water? Well, that happens at 3. That x value, that point in time, is when I stop going from being a submarine to now being an airplane in the air. So from -infinity all the way to the left, up until 3, at that point in time, I was a submarine. Now from 3 until 5, it's just a very short flight. From 3 to 5, that point in time, I am above the x-axis. I'm positive. So I'm going to go ahead and write that in my positive interval. And then after 5, I go back to diving below the ocean water, and I'm a submarine for the rest of my life. From 5, forever and ever and ever, to infinity. And so it doesn't matter if you're going up or down or anything like that. It matters being above or below the x-axis. And you always state these intervals in terms of x values. That's why there's an x and a colon in front. These are x values, not points. So I hope after doing that problem, that was a big problem, you guys are really starting to remember everything that we've talked about. And we would expect you guys to be able to do some of this on your own, especially after you get some more review practice. The only other thing that we need you guys to keep fresh in your mind is this idea called average rate of change. This is something that pre-calculus talks about, and then calculus, believe it or not, is built entirely almost on this idea. Average rate of change, if you remember, is just the slope between a starting point and an end point. Okay, a lot of times they have some special symbols that go with this. But this question says, for the function above, find the average rate of change of f of x over 0 less than or equal to x less than or equal to 3. So from 0 as my starting point to 3 as my end point. Beginning to end. What's my average rate of change? What's my slope? So if you remember from average rate of change in that section, we a lot of times use this Greek letter, delta. Delta y over delta x, because it's rise over run, and the y values are going up and down, and the x values are the running values left and right. And there's a formula that goes with this. Y2 minus Y1 over X2 minus X1. But you're like, what do those things mean? What do those letters mean? Well, Y2 and Y1, X2 and X1, those all come from points. So the subscripts, the small numbers, tell which point. Is it the first or the second point? And so we need to have 2 points in order to even do this. And that's where that starting and ending value come in. So we're starting at 0. 0 is an X value. What is the Y part of that point? 0, comma, and if you are clever, we've actually already discovered the point that happens at 0. 0, comma, negative 15 is the Y-intercept. It's something that we've already written. It's something that we've already graphed. So we're starting at 0, negative 15, that Y-intercept. But if we're ending at 3, well, where's the point at 3? And if you are going back and looking, 3 was an x-intercept, 3, comma, 0. So my starting point is 0, comma, negative 15, and my ending point is 3, comma, 0. That first point is x1, comma, y1, and the second point is x2, comma, y2. All you have to go and do now is plug the specific numbers in for their specific variable. So it will look like this. 0 minus negative 15. And if you remember, subtracting a negative makes a positive in the end. Just like that. On the bottom, for x2 minus x1, it is 3 minus 0. If you go ahead and take 0 plus 15, which is 15 on top, 3 minus 0, which is 3 on bottom, 15 divided by 3 ends up with 5. Now what does that mean? For us, that means the slope between 0 is your starting point and 3 is your end point is a slope of 5. That's a pretty quick increase, a pretty quick rate. Some different values, if I tried to look from a different start to a different end, they might not change as fast. Or maybe they change faster. But on average, between the start and stop point here, we're changing and we have a slope of 5 over 1 over 5. I hope this video helped you guys understand the notes a little bit better. And I hope that some of the visuals that you saw will help you remember how to solve some of these questions. This is a very important target. The fact that we are combining everything at the same time and going back and reviewing what we've done is incredibly important. Hopefully it's nothing new, or if it was something you were a little bit rusty at, now you know how to do it. If you like this video, go ahead and hit subscribe. I'd appreciate it. Hope it helped. And as always, we'll see you guys next time. Take care.